Okay, in this assignment, we're going to look at three different types of interest. We're going to do simple interest, compound interest, and compounded continuously. Each one of these have a unique equation or a unique formula to use. And we're going to start with simple interest. Anytime we're dealing with money, let's go ahead and round to the nearest cent. I'm not going to say that for every problem, but that should just be the common value to round to when you're dealing with money. So with the simple interest equation, we have A equals P times 1 plus APR times Y. And you may see this in a couple different formats, but that's going to be the format for our class. And I'm going to give you the shorthand for each one of these. A stands for amount, and we want to think of this as our final amount. P really stands for principal, but we want to think of this as the starting value. And I would use the word amount there, but we're going to think of that as the starting value. 1 is the number 1. APR, you want to think of that as what is my rate, and Y is going to be how much time, and it has to be in years, and that's important. We're going to see some that aren't given to us in years, and we will have to convert to years, and it'll be a pretty easy conversion. But that's the equation that we're going to use for these first couple. Just like my previous homeworks, I'm going to do the odds in this case, and I'm going to let you do the even ones. So you should be able to match up the odd ones with the even ones and work these out. So John invests $200 for 8 years in an account that grows at 5% simple interest. As soon as you see that, what I suggest you do is to write the above equation or the above formula down for each one of these. All right, so I rewrote what I see here. And then I'm asking how much money will John have after 8 years? So now I want to start filling in what I have. He started with $200. That was my original amount. The rate was 5%. And if I say 5%, I always have to turn that into a decimal. So that would be 0.05. You can always put a 0 in front of it, so 0.05. And he does this for 8 years. So my years is going to be 8. And that's going to give us our final amount. So I'm going to grab my calculator. And I should notice that say that APR, annual percent rate, is the same thing as the rate whenever we're dealing with simple interest. So for this one, I have 200. And once again, I'm just going to do all my calculations off to the side. If you have questions about how to enter this in your calculator, please let me know. I'll be glad to help you out. But essentially, you want to enter it exactly as you see it that I've written on the screen, except you do want a multiplication sign there. All right. So I do all of this, and I get A equals $280.00. So I got $280 is what John would have after 8 years. So I'm going to leave number 2 for you. Number 3, Janet invests $1,500 for 48 months in an account that grew at 8.3% simple interest. So once again, as soon as I see that simple interest, I'm going to zoom out a little bit so you can see what I'm doing. I would copy down the equation that I'm going to use, which is A equals P, 1 plus APR times Y. And then I just fill in the values beneath it. So she invested $1,500. That's how much she started with. The rate was 8.3, so I need to turn that into a decimal. So 0.083, and you can always add a 0 in front of the decimal. And then she did this for 48 months, which that's not a year. I need to convert that to years, 48 months. Over 1, there are 12 months in 1 year. So that cancels. I have 48 divided by 12, which gives me 4 years. Now you probably could have did that without using dimensional analysis, but I just went ahead and used it. Okay, so now I have 1,500 parentheses 1 plus 0.083 times 4. Close your parentheses. Close them twice if you wrote it the way I did it. And I get A is equal to, and that was what it was equal to the whole time, 1998. And once again, I don't have any cent with this one either. Okay, so if you get a decimal, just make sure you round into the nearest cent. So number 5, I have Joey invest $800 for 15 months in an account that grew at 3.4 simple interest. How much money does he have? So I have the same equation. A equals P times 1 plus APR times Y. He started with $800. This time, my rate is 0.034, and just keep in mind you can always add a 0 in front of that decimal, but you can't add them behind the decimal. So 0.034 or 0.34 times, this time my months is not going to be a whole number value year, so I'm going to make sure that I do dimensional analysis here just to show you what you're always going to get. 15 months over 1, and I have 12 months is 1 year. So then the word months would cancel, and if I multiply across the top, I get 15 times 1, which is 15. If I multiply across the bottom, I get 12. So an easy way to convert months by years is just to take that month and divide it by the amount of months in a year, which would be 12. So I'm just going to leave it a fraction, 15 over 12. That's equal to A. So now I'm going to grab my calculator, type in 800, parentheses, 1 plus 0.034 times 12 divided by 15, close your parentheses, press enter, and I get this time 821.76, and that would be dollars, and I guess I should have written a dollar sign on all of mine. I want to double check I have. Okay. So for 7, it's going to be a little bit different. I have Rob wants to save $10,000 to buy a truck. He's going to invest his savings of $8,000 into an account that grows at 4% simple interest. How long will it take Rob's account to grow? And I want you to round your answer to the nearest tenth of a year, and it'll produce the answer in a year. But the same for y'all with number 8. Just round this to the nearest tenth of a year. But this time I see the word simple interest somewhere in here. So I know that I'm still using this equation. All right, but this time when I go to fill in the stuff I have how much Rob wants to end up with. So this time I actually have the amount. I also have what he's starting with, the $8,000. I have the rate. I need to turn it into a decimal, so 0.04. What I don't have is the y, so I'm just going to leave that my variable. So this time I'm going to have to do a little bit of work. I'm going to divide by 8,000 on both sides. You can turn this into a decimal if you want to, or you can keep it a fraction. But I do suggest you reduce it just to make it look a little bit easier to work with. But this is 1.25 equals 1 plus 0.04y. Now the parentheses are gone because they're not being multiplied by the 8,000 anymore. So to solve for my y, I'm going to subtract 1 from both sides. It's going to cancel here. That gives me 0.25 or 0.25 equals 0.04y. I'm going to divide by 0.04. So I have 0.25 divided by 0.04, and that gives me 6.25. And since I said round the answer to the nearest tenth, that would be y equals 6.3 years when I round that to the nearest tenth. So that time we were still using the same simple interest equation, but what was unique about that one is we were solving for y. So just keep in mind this goes for the same way that we would solve for any variable, just the order operations, and we want to work backwards in order to get that y by itself in this case. All right, we're going to move on to compound interest. This is compound interest when I'm given the amount of times it was compounded, and n is the number of times something is compounded. So when I go through this one, A, I think of that as the same thing. It's the final amount. P stands for principal, but I think of that as the starting amount. And I think I called it the starting value or the initial value last time, but same thing. APR this time is still going to be the rate, but this time it will be listed specifically as APR. And then Y is still the time, and it has to be in years. But this time I have this N and this N, so we have two N's, which stand for the number of times compounded. That's what N stands for, and it will tell you most of the time that it's compounded a specific number of times, but it will tell you that in words. So something that you'll see is daily. If you see daily, that means 365. Now, there are sometimes that we will see a banker's rule that says daily is 360, but unless you see banker's rule, we assume that there are 365 days in a year, so it would be 365. Weekly would be 52. Monthly would be 12, right? These were all my N values. And then if we jump over here, quarterly means your N is 4. Semi-annually means your N is 2. Yearly, your N is 1. There may be some other ones that you may use in your Math 143 class or your other class, but for this class, that's all, or for this assignment, that's all that I'm going to use. All right, so let's look at this. I have John invest $200 for 8 years in an account that grows at 5% APR compounded monthly. So as soon as I see the word compounded, I look right behind it and I see monthly. Then once again, I know that I'm using this equation up here. So I want to write it down. A equals P, 1 plus APR over N raised to the N times my Y, right? And some people will put that NY in parentheses, and depending on which calculator you have, I suggest that you go ahead and put it in parentheses. So it can't hurt to put it in parentheses, even if it's not necessary, depending on your calculator. So let's go ahead and start filling this in. He invested $200, so that was his initial amount. The APR is 5%. You must convert that to a decimal, so 0.05. N is monthly, so N is going to be 12. And then it's raised to the 12 times the number of years, which was 8. So all I'm doing at that stage is just pulling out the necessary information. And I'm going to go to my calculator and type this in. Let's see if I can get the calculator up. So I'm going to type in just this one because this one is a little bit trickier to type in. Okay, so I'm going to type in what I have on the left, which is 200. I open my parentheses. I have 1 plus. Now you could put this next part in parentheses, but you don't have to. But if you do, make sure you close it. So 0.05 divided by 12. I am now going to close my parentheses, so everything is just as I see. And I'm going to raise this to the 12 times 8. So I'm going to raise this. And my calculator, it kind of raises it so the parentheses are not necessary here, but just to get in the habit of it, let's go ahead and open our parentheses, 12 times 8. And let's close our parentheses and then press enter. And this is going to be my value, $298.12. So $298.12. A equals $298.12 would be the amount if it was compounded at 5% monthly. So really quick, one thing I want to show you, if we look at this, this was $200 for 8 years at 5% interest. If we look at the very first one that we did, this was $200 for 8 years at 5% interest, and he only earned $280. The one we just did, so remember that value, $280 for the first one. The one we just did was $298. So the more times something is compounded a year, the more money you're going to make off of that investment. So this one was compounded monthly. It was the same rate, the same amount of years, the same initial value, but the simple interest one was only compounding that one time per year, and that's what simple interest means. It's only getting compounded once per year. So just keep in mind, you'll see how your money grows the more times it's invested, depending if the rates are the same or not. If the rates are different, obviously you'll have to do your calculations to figure out which one grows the quickest. So I'll leave number 10 for you. Number 11, I have Janet invest $1,500 for 48 months in an account that grew at 8.3 APR compounded quarterly. So as soon as I see that, I have A equals P times 1 plus APR over N raised to the N times Y. I'll go ahead and put my parentheses. So 1,500 was her initial investment. The APR was 8.3, and that should have been percent. So 0.083, and I'll make sure I correct that on your homework examples, but 0.083. The number of times compounded was quarterly, and we can look back at the chart, but quarterly means 4 for our N. And then up here, the N is 4 again, and the years, this time was 48 months, so we can do 48 months. We can divide by 12 months. That gives us our years. So that gives us 4 years when you do convert months to years. So that's going to be a 4 here for my y. And I'm going to type this in my calculator. 1500 parentheses 1 plus 0.083 divided by 4 raised to the 4 times 4. And the calculator I'm using off to the side, I have to put those parentheses right here. But the one I showed you on the screen, I didn't have to. So just to get in habit of it, make sure you're using your parentheses in case you ever switch calculators. So it's 2083.54, and that would be dollars. So this was $2,083.54. So number 12 is a very similar setup. Number 13, Joey invests $800 for 15 months in an account that grew at 3.4% APR compounded weekly. So as soon as I see compounded weekly, go ahead and write down the formula for compounded when I know what my N is. And it's not compounded continuously. So he invested $800, so that's how much money he started with. The APR was 0.034 in weekly. If you look back at the chart, weekly was 52. So I'm going to have another 52 here. And then years, this is 15 months, and I showed you that trick a while ago. All we need to do is divide that by 12. So I'm going to type that in my calculator, 800 times 1 plus 0.034 divided by 52, close your parentheses, raise it to the 52 times 15 divided by 12, close your parentheses, and we get $834.72 when I round to the nearest cent. And we can always double check our answers and see that they should kind of make sense. If I invested $800, I expect that to grow. If it's at 3.4%, it's growing at a decent rate, but it's not going to be something outrageous. So you can see that if I had it in there for 15 months, I made a total of $34. And now is also a good time. Sometimes you'll see these things worded differently, where if I say how much money did Joey make on his investment, we take the final amount, which would be 834.72, and we subtract the original, because that's how much money he already had anyway, right? So I would subtract that, and I would get $34.72 is how much money he made, which is different than asking how much money does he have. So pay attention to the way it's asked on your test. We can ask these questions in different formats. All right, so the last few examples, I'm not going to do many of these, is compounded continuously. We have a new equation for this one. It's A equals P times E, and that's a multiplication in there. A equals P times E raised to the APR times Y. Once again, depending on your calculator, you may not have to have these parentheses. I'm going to go ahead and add them back here just to denote that that is being raised both to the APR and the Y. A, once again, final amount is how I think of it. And I'm not using the mathematically correct terms here, but P is your initial amount or your starting amount. And I think I've used that a couple different ways. But E is actually Euler's number, right? E is the number E, right? So that's a number, that's not a variable. APR is your annual percent rate. We just want to think of that as your rate. And your Y is years. So same letters, just kind of in a different rearrangement here along with that E. And we only use this one when we see the word continuously. Sometimes you will see compounded exponentially. And I may be spelling that wrong here. I don't have spell check when I type it out this way. All right, but if you see compounded exponentially or compounded continuously, then we're going to use this equation. So John invests $200 at 8 years in an account that grows at 5% compounded continuously. So as soon as I see that, I rewrite my equation. And I do think if you get nothing else out of this video, that's the most important part, is you want to always just start with the equation and then just fill in what you know. He invested $200, so this would be $200. E is E. This was at 5%, so that would be 0.05. And this was for 8 years, so times 8. I'm going to put parentheses around that. And I have A equals this. I'll grab my calculator for this one too. So this was 200 times E. E is going to be on different locations on different calculators. I can see here in yellow, and make sure you're watching this in HD. I have E raised to the, if I hit second and then this ln, I get my E, and it's raised to 0.05 times 8. I'm going to go ahead and open up parentheses here, although with this calculator it's not necessary, times 8, and close my parentheses, press enter, and I get $298.36. $298.36. So just like I did on the previous example, this was the same one where we had $200 8 years for 5%. And if we look at it when it was just compounded, it was $298.12. And you can see that it didn't go up much, but when we compound it continuously, it was more profitable to have it in an account that's compounded continuously, given that the initial amount, the years, and the rate stayed the exact same. All right. Last example here, I think. Yep, last example. I have Janet invest $1,500 for 48 months into account growing at 8.3%. Again, I lost my percent time, compounded continuously. So this is A equals P times E raised to the APR times Y. All right, so I have $1,500. My APR is 0.083. And 48 months would be divided by 12, which would give me 4. So I'm going to kind of shortcut this a little bit to speed up the video. That's going to be my amount. So 1,500 times E raised to the 0.083 times 4. And I get 2090.63. And that would be $2,090.63. 4 years compounded continuously. If I had $1,500 at 8.3%, that's how much money I would have. So that's going to conclude this video. I did all the odd ones. I'm going to leave the even ones for you to do.